Imagine for a moment, if you will, the hands of a clock ticking anti-clockwise. What if time itself flowed backwards? Picture a world where the future becomes the past, and the past becomes the future. Sounds absurd? Impossible even? Well, that's what we're here to explore. In our everyday lives, we experience time as a one-way street. We grow older, not younger. We remember the past, not the future. This is the arrow of time, always pointing forwards, never backwards. It's a fundamental aspect of our perceived reality. But what if it didn't have to be this way? What if the arrow could be flipped? What if we could provoke the flow of time to reverse its course? It's a concept that challenges our very understanding of the universe, a concept that, while counterintuitive, is utterly fascinating to ponder. So let's dive into the rabbit hole and explore the intriguing concept of time flowing backwards. Time, as we understand it, moves in one direction. It marches forward, never ceasing, never reversing. Our grasp on time is rooted deeply in our day-to-day experiences. We wake up in the morning, go about our chores, and then finally retire for the night. This cycle repeats itself day in and day out. It's a sequence of events, a chronology of actions that we have come to identify as the forward flow of time. We perceive time through the lens of causality. Every cause has an effect, and every effect is the result of a cause. It's a complex dance of events, one leading to another, creating a domino effect that we interpret as the progression of time. Consider a ball rolling down a hill. The gravitational pull causes the ball to move. It gathers speed, reaches the bottom, and eventually, it stops. This sequence of events is how we comprehend time. The ball can't unroll up the hill. The sequence can't be reversed. It's this linearity, this one-way street that forms the backbone of our understanding of time. But isn't this concept of time a bit too human? We perceive time in this way because it's how our brains are wired. It's a product of our evolution, our survival. It's what we see, what we experience. But could there be more to it? Could there be a different perspective? A different understanding of time that goes beyond our human experiences? Our understanding of time is tied to our perception of reality. But reality, as we're coming to understand, isn't always as straightforward as it seems. Our senses, our experiences, they only paint a fragment of the bigger picture. There's so much more to reality, to the universe, than what meets the eye. So let's question our understanding, let's challenge our perception. Time, as we know it, is linear. It moves forward from the past through the present and into the future. But what if this isn't the whole truth? What if there's more to time than this unidirectional flow? But what if we flip this understanding on its head? What if time could flow backwards? In the world of theoretical physics, the idea of time flowing backwards isn't as far-fetched as it might seem. Now, to understand this, we first need to grasp the concept of entropy. Entropy, in layman's terms, is the measure of disorder or randomness in a system. A key principle in physics is that, in a closed system, entropy always increases. This is known as the second law of thermodynamics. In other words, things naturally progress from order to disorder, like a deck of cards shuffling into randomness. This principle gives us what we call the arrow of time. If you think about it, most of the fundamental laws of physics don't distinguish between past and future. They're time-symmetric. But when we look around us, we see an obvious direction to time. We age, buildings crumble, stars burn out. All these events follow the arrow of time from low entropy to high. But here's where things get interesting. Theoretically, there's nothing in the laws of physics that prevents entropy from decreasing. It's just incredibly unlikely. Imagine trying to unshuffle that deck of cards back into perfect order. Not impossible, but highly improbable. This opens the door to the concept of time reversal. If entropy could decrease, the arrow of time could, in theory, reverse. Eggs could unscramble themselves, shattered glass could piece itself back together. The past could become the future. But before you start dreaming about rewinding your mistakes, there's a catch. This isn't about time travel. In a reverse time scenario, you wouldn't remember the future, because your brain's entropy would also be decreasing. It's more like running a film backwards. And there's another twist. In the world of quantum mechanics, time reversal symmetry is already a proven principle, but that's a story for another scene. So the physics allows for it, but does that mean time can actually flow backwards? Let's explore further. When we delve into the quantum world, things start to get a little bizarre. As we journey deeper into the realm of quantum mechanics, it becomes clear that our everyday understanding of time may not hold up. In this domain, the laws of physics are time-symmetric. Now, what does that mean? It implies that these laws operate the same way whether time is moving forward or backward. This is in stark contrast to our macroscopic world where the direction of time is unidirectional. It always marches forward. Let's consider a simple quantum experiment, a particle bouncing off a wall. In the quantum world, if you were to reverse time, the particle would trace its path back to its starting point. The laws of physics would look exactly the same running forward or backward. This is the symmetry we're talking about. Now, let's take a moment to understand the implications of this symmetry. It suggests that there's no fundamental law in quantum mechanics which prohibits time from flowing backwards. That's right, in the quantum realm, time could potentially flow in reverse. However, before we get too excited about the prospect of time travel, let's ground ourselves. This time reversal symmetry is a mathematical abstraction. It's a concept that works well in equations, but doesn't necessarily translate directly into our tangible everyday world. In fact, in the real world, we have something called the arrow of time, which is based on the principle of entropy. Simply put, entropy is a measure of disorder, and it always tends to increase over time. This gives us our familiar forward rush of time, and doesn't quite gel with the quantum world's time symmetry. But just because it's possible in the quantum world, doesn't necessarily mean it's possible in our everyday world. So while the quantum world tantalizes us with the possibility of time flowing backwards, our everyday experiences remind us that time, as we know it, steadfastly continues its forward march. If time could flow backwards, the implications would be profound and mind-boggling. Imagine waking up tomorrow remembering today as if it were already past. This is one of the many paradoxes time reversal presents. Remembering the future is a concept that seems straight out of a science fiction novel. However, in a world where time flows backwards, it could very well be the norm. Let's delve deeper into this idea. In our current understanding of time, we remember the past because we've experienced it. The future, however, remains unknown. But if time were to flow backwards, this fundamental aspect of our existence would be flipped on its head. The future would be our past, and the past our future. Now consider the everyday events unfolding in reverse. A shattered glass would reassemble itself, jumping back onto the table. Rain would fly upwards from puddles back into the clouds. The sun would rise in the west and set in the east. It's a world that seems alien and completely counterintuitive to our sensibilities. Moreover, the implications of time flowing backwards would extend far beyond just the reversal of events. It would challenge the very foundations of physics as we know it. The second law of thermodynamics, for instance, which states that the total entropy of an isolated system can never decrease over time, would be violated. This law is fundamental to the arrow of time, the one-way direction or asymmetry of time. If time flowed backwards, we'd be living in a universe where order spontaneously arises from chaos. Yet there's a caveat. As tantalizing as these scenarios are, they currently reside within the realm of theoretical physics, far from our everyday experiences. The notion of time flowing backwards is a fascinating thought experiment, but it's yet to be substantiated by empirical evidence. So, while the idea of time flowing backwards is fascinating, it remains firmly in the realm of theoretical physics. But who knows what we might discover in the future? So there you have it, a journey into the concept of time flowing backwards. We've navigated through our traditional understanding of time, a linear progression from the past to the future, and questioned whether it could possibly flow in reverse. We've delved into the theoretical basis of time reversal, exploring the fascinating idea that in the quantum world, time might not be as one-dimensional as we perceive it. We've pondered over the mind-bending implications of time flowing backwards, from reversing entropy to the possibility of living our lives in reverse. And we've taken a peek into the current state of research on this intriguing topic, a field that's still in its infancy but growing rapidly. While we may not have definitive answers, it's always exciting to question and explore the mysteries of our universe. Until next time, keep wondering, keep questioning, and keep exploring.